Hello, Mike Panaki here with Network Protocol Specialists. And one of the questions that I get from time to time in class and from former students is what is the difference between TIA-568.3-E STD and REF? So in this presentation, we're going to take a quick look at what the difference is between these two test limits on the Fluke Network's CertiFiber Pro. So let's jump over here to the document that's going to tell us the difference, and that is our limit lines. So our test limits on the versive are documented in the limit lines. So we can come in, we can see our limits for copper, our limits for fiber tier 1 and tier 2. So you say, Mike, where do I get this document? What you do is you go out to flukenetworks.com. You go to support and downloads and updates. And that will take you to this screen right here. Scroll down to where you find the versive limit lines. Now the current version as of the recording of this video is version 6.11 build 2. The current version of the limit lines out there on the website is version 6.9 build 2, and what we'll find is, especially for the topic we're talking about today, that is great. That is the values are the same in 6.9 and 6.11, so that's valid. Now when you open up that PDF and you search for TIA 568.3-E, you'll find something that looks like this. Now, that's great. We can see it. It's kind of hard to compare them with that tiny font. So what I did is I made it a little bit easier to read. So let's take a look, starting with multi-mode, at what the difference is between TIA 568.3-E, STD, and REF. And what is the difference here? Well, REF is when we're using test reference cords. And we know that when we're using the CertiFiber Pro for going out and certifying networks, we really should be using the test reference cords. These have reference grade connectors and provide a much better connection. And they give us more accurate, repeatable results. So in this case, if I'm using Fluke Networks test reference cords, we come over here and we see our adapter loss is 0.75. Now this is for any embedded adapters within the link. And don't worry, we're going to go through an example as soon as we get done with these tables. Now here we see for STD, the loss allowed for the first connector and the last connector is 0.75. That's because with standard connectors, we allow 0.75 dB of loss. Our splice loss is 0.3 dB. Our loss per kilometer at 850 nanometers is 3 dB per kilometer, and our loss at 1300 is 1.5 dB per kilometer, and our link limit is 2000 meters. Now here's where the difference lies, and that is the amount of loss that we allow for the first connector and the last connector. And we're going to see that this is consistent through all of these. Because we're using test reference cords, which have a much better connector and lower insertion loss for those connectors, we allow less loss for that first and last connector. So if we are using the REF limit, we allow 0.5 dB for the first and last connector. So what is the net difference here? The net difference is when we're using the REF limit, overall our limit is going to be 0.5 dB less than if we use the STD limit. Now this is to make sure that we're fair when we go in there and do that testing. We've got a better connector, so we should allow less loss. Now I'm going to tell you right now, the most important thing is what is the customer specifying. So if you're the one going in and doing the testing, make sure you do whatever the specification says. That is the most important thing. Okay? Do what the specification says. Now, if we come down here to single mode, we find that with single mode, if we're using the STD limit, we allow 0.75 dB for the first and last connector, 0.75 dB for any embedded connectors, 0.3 dB for splices, and then depending on the type of fiber we're using, if we're using inside plant fiber, we allow 1 dB per kilometer at both 1310 and 1550. If we're using outside plant fiber, for OS1, we allow 0.5 dB per kilometer at both wavelengths. If we're using OS2, we allow 0.4 dB. But you'll see that the difference between the STD limit and the REF limit is the amount of loss we allow for the first and last connector. So let's go in and let's draw this out. So we're going to draw out a sample link right here. So what I've got is I've got my CertiFiber Pro module on my main connected to a fiber on this patch panel. We're just going to show this for one fiber. Okay, normally we would be testing 2 fibers. Over here, I come out of my single mode light source right here on my remote and connect it up to this end. And I've got a patch in the middle that's connecting these 2 patch panels together. So here, we're going to use the TIA-568.3-E REF test limit. Okay, we'll do ISP single mode. So in this case, I'm going to allow 0.5 dB of loss for that first connection because my REF limit says 0.5 dB for the first and 0.5 dB for the last. Now, I spliced on pigtails in this case. I've got a splice here and I've got a splice there. So that's going to be 0.3 and 0.3. Okay? Now, I've got a connector here. Well, that's embedded, 0.75 dB. Okay? I've got a connector here. That's an embedded connector. It's in the middle of the link, 0.75 dB there. I've got a splice here and a splice here, and we'll say 0.3, we'll say 0.3. Now, let's say I have 100 meters of fiber here, and I have 200 meters of fiber here. So let's add all this up and see what our limit would be. So if I take 0.5 plus 0.5, that's 1, plus 0.75, that is 2.5. So I would be allowing for my connectors 2.50 dB of loss. Now for splices, I've got 4 splices at 0.3 dB. That's going to be 1.20 dB of loss for splices. Now for fiber, because this is ISP, if we went back to that chart, we'd see that this is 1 dB per kilometer. So that means 100 meters is 1/10 of a kilometer. So that's going to be 0.1. This is 2/10 of a kilometer. That's going to be 0.2. This jumper right here, I don't know, let's say this is 2 meters. That is so short, I don't care. So here I get 0.3 meters. So we'll say our loss for fiber is 0.30 dB. Okay, so when we add all of this up, we get 0, 0, we carry the 1, we get 4.00 dB of loss for this link. Now, if I use the STD limit, I would allow an extra 0.25 for each end. So this would be REF. Over here, STD would give me 4.50 dB. So that is the difference between the STD and the REF limits. I hope that this was useful. I hope that you got some good information out of here as far as what the difference is, and the most important thing to remember, what does this contract or the warranty requirements specify. If it says REF, be sure to use REF. Otherwise, you're going to be allowing an extra half a dB of loss. Your test results may not be accepted. You're going to have to go back and retest everything, and I'd hate to see that happen. One last thing, remember the TIA-568.3-E limits are length limits, meaning that we must enter the correct number of splices and connections for the link in order to calculate the right test limit. All right, well that's it for this session. I hope it was useful. Please like this if you found it useful and subscribe to the channel. Check out our other videos. We'll see you later.